Welcome everyone. I'm really pleased to see so many people here. And I'm going to make a start now. Firstly, apologies from Ingrid, who is unwell. But she'll be making her welcome speech on Friday morning, after we've done everything. So on Friday, we're going to have a Pecha Kucha where all the work that you guys as students do this week will be shown. I think, if I can ask Milad, the schedule will be posted on the website tonight. There's a couple of other things that we're in the process of doing and not quite ready yet. So this world map, tomorrow there will be drawing push pins and little luggage tags. So you can push in, and we'd like to have everybody push in a pin where their home country is, and where they can write on the little tag what they think the principal climatic issue is. And after today's presentation, I hope you'll get some idea of what we're looking for. But the amazing thing would be, at the end of the week, we would have a world map of not only where everyone from the AA comes from or is interested in, but also what they think are the principal issues in their home country. Okay. So I think we're ready to go. How do we know where we are with climate? You'll read a lot of figures and there's lots of articles and things that will tell you. So the first part of what I'm going to show you is how do we know where we are now? And the second part is where are we going? I'm going to show some very reliable sources. And in that room, South Jury room, there are 3 screens that will be available for the week. And they're already pre-tuned to particular sites, and we'll talk a little bit about those at the end. Okay. Climate change is normally measured from around 1850, and I wanted to show this. It's called Wander Above the Mist, painted in 1818 by Caspar Friedrich. And I wanted to show you for 2 ideas that were important at the time. One is, although it's a man, the idea was that every young person when they came of age could go out across the world and climb somewhere high up and take a view of the whole of nature. And the second thing about that is, nature was regarded as in the dominion of man. That is, you could do what you liked with it because it was mankind's right to do anything they wanted to nature. Cut down the trees, breed all kinds of animals, do anything, exploit it in any way you wanted. And a kind of third point, nature looks really clean in there. And nearly all the paintings we see of those periods are of a pristine, unspoiled nature. And somehow that set of relationships of unspoiled nature, humans have the right to do anything they want with it, has persisted to our detriment. Okay, so the first thing about how to know where we are, there are some very good, reliable sites that you can rely on the information, and NASA is one of them. And during the week, you'll be able to access all the NASA sites in the South Jury room. Okay? And NASA constantly updates by the hour worldwide weather and climate information. And you can pick out actually any particular satellite you want and follow that, or you can look at the aggregate summaries for them. And what they do is provide this kind of information. Carbon dioxide count. We'll have a little bit more about carbon tonight, both with Kira Malik and with Tom and Giles in their lecture tonight. We are past what in my generation we were taught is the critical threshold was 400 parts per million. It's thought that the period we're measuring from that was somewhere just over 200 parts per million. 215 or something like that. So we're almost double where we were in 1850. And the reason why that's important is the carbon dioxide molecule is a total bitch for heat. It loves it and it retains it. Methane is even stronger about doing that. Okay, so that's when they talk about greenhouse gases, what it means. It's producing something like a heavy overcoat over the world. Other data there that's important, I'll talk to you about a little bit more. Sea level rise is something I'm going to be looking at with you during this week. So this is a little graphic on the rise of temperatures each year. We should remember these are average temperatures, because it's convenient to talk about the average for the world. But the average is not your friend. Yeah. If you live in Reykjavik, these are meaningless because your temperature increase is far higher than this. Yes. So there are places in the world where the temperature increase is much above the average, and a few places where it's below. And that's the point about averages. Yeah. So if we made everyone in the room stand up and measured your height, we would get an average. The average age of an AA student this year is 24 years. But I guess not all of you are 24, right? So you will understand what I mean about average. And the points I'm going to show you later today is how you find out in your home country or the country where you're studying and interested in, what are the predicted effects, what is happening now, what is likely to happen by 2050, and inshallah when you reach this age, in 50 years' time, what the predicted changes in that country are. Okay. This summer has been crazy for weather. Nearly all around the world, and most of you will have experienced some of it. July was the hottest on record, and actually so was August, and so was September in parts of the world. And if you look at that, you can see the differences in some areas. So the very dark parts we're seeing are about 4 degrees above what would normally be expected. Okay. And many of you live in countries where there have been severe wildfires this year. And if we look at that, Canada is probably the most extreme, but it's happened all over Europe as well as all over the northern parts of the Americas. And in fact, Canada fires, there were people choking in New York City during the summer from the smoke from the Canada fire, so that you can understand the scale of it when the smoke drifts across half a continent. I think this is also from NASA, where we start to look at the density in different areas of carbon, burnt carbon in the atmosphere. We think it's kind of more than 90% certain that this current year, 2023, is going to be the hottest year that's ever been recorded. And there's been some amazing temperatures, India and China particularly. And here in the UK, people complain when it gets 30, 35 degrees. And we'll talk more about the eccentricities and the infrastructural Dadaism of the English attitude to climate in a little while. If you live anywhere near the Mediterranean, you saw a lot of this this summer. And each year it happens, it seems to take governments and agencies by surprise. But it is entirely predictable and has been predicted for more than a decade. Things dry out, it gets hot, there's no water, small amounts of small flames, discarded cigarettes, will set off huge fires. Some ecologies, like Australia, have evolved certain kinds of trees that rely on fire. But mostly, Europe and the Northern Territories are populated by trees and plants that don't need fire and can't really resist it. Someone asked me in my seminar course last week, or the week before, well, where does all the water go? And of course, it doesn't get destroyed. Yeah? It rises up, just like when you boil a kettle in your kitchen, and you can see the steam rising. Hot air carries more moisture than warm air or cool air. And what we're starting to see is at the same time as we're seeing severe droughts and heat storms, we're also seeing very intense rainfalls in different places. And the pattern in this year where it's falling is in the different places, and I'm going to show a little bit why. Yeah. It's also the intensity changes. Because there's more moisture held in the air when it does rain, a huge amount comes down, more intense than we're used to. And in many countries, especially this one, there are no urban designs that are optimized to cope with that intense rainfall. Like many countries, but England particularly has a problem. The river is in the same place it was last year. That hasn't changed. And the rain comes from up there, and that hasn't changed. Okay? So it's entirely predictable that it will flood. This year's excuse from our Ministry of Environment was that the rain came from a different direction. Yeah. Planning and designing for living in these conditions is really super important. And one of the most basic things is designing for floods. I'm not going to give the answer. I've had to do that today, but I'm hoping it's one of the things we see towards the end of the week from students. Okay, so at the same time as we're seeing the fires and tremendous heat in parts of India and parts of Europe, we're also seeing tropical storms on the other side of the world hitting California. Tropical storm is a kind of technical word for a hurricane. Okay, so this was category 4, I think. But we're seeing all over the world different anomalies of temperature. Places that weren't normally this hot are getting the heat, and places that weren't normally drowning or flooding are getting the water. You see a little bit in the press, people saying, well, we'll just get used to that. This is a new normal, but it isn't. Okay. It's going to get hotter than this in your lifetime, and probably in the next few years. It is going to get hotter. So this is not a process that has an end result. It's a dynamic that's continuous. And it started arguably 150 years ago, but it's got much more intense since around 1960. And it will carry on getting more intense in the next 20 to 25 years and so forth. Okay. This is one of the reasons. It's called El Niño. There is a fluctuation in the temperature of the oceans. The oceans absorb most of the heat from increased heat. But this is a fluctuation that always occurs. And it's partly to do with the deep circulation around the world of cold water that comes from the Arctic and sinks down and takes somewhere around 1,000 to 1,500 years to travel around the world, and it rises up on the west coast of South America. But every now and then there's a fluctuation in that, and the surface of the water becomes really, really hot. And that fuels and changes other patterns in the world. The biggest thing it changes is the atmospheric circulation. So these are called the Hadley cells. The bit in the middle is the equator, where you'd expect it to be. It's where all the deserts are. It's the driest bit, because that's always the hottest bit around the fat part of the world. And what it does, if you look at the right-hand image, it changes that, and it disrupts the jet streams, which are these little yellow ones that lie in between the cells. And typically those, instead of being a nice even pattern, get bent down and get locked into a different pattern. So it's important you can understand and learn about these things, but it's important to understand this as a dynamic, as something that changes, that has some years more change than other years, and what lies ahead are even more changes. So these are the tipping points. You can think about this. It's 4 o'clock in the morning and you've been up all night dancing, and you're in a little cafe having a cup of tea or something, and there's a pile of sugar. Yeah? And you hold your hand up and you take the sugar caster and pour it onto it, and it forms a little pyramid. So what you can never tell is it will take one grain to make that pyramid collapse, but you can't predict which one. And tipping points are like that. We know, and mathematicians know, and it's been intensely studied, that there is a critical threshold called the threshold of stability. Yeah? And a small amount of change will precipitate a big collapse. Why that's important is because all of those tipping points are in subsidiary systems that are all linked. And this is a kind of simplified way of looking at the potential links. Okay, so I'm going to pick one of them, which is the Greenland ice sheet. So to reassure you, it's not going to melt tonight. And every scientist agrees Greenland ice sheet is going to melt, and what they argue about is how fast and when it's going to happen. The critical threshold for that is somewhere between 1.7 and 2.3 degrees. We have been past 1.2 degrees this summer. It will come back a little bit in the winter. But it's thought, certainly before you become middle-aged, sorry to pick on you, Mark, eventually you will be, yeah? We're likely to pass that threshold. It's already melting, of course, but beyond that threshold, it will not be stable, it will not hold together as a single ice sheet. If it's unfortunate enough and you live long enough, inshallah you will, live a very, very long time, this will produce a huge amount of changes in the ocean. It's all going to be fresh water, of course, so that changes the salinity. Salinity changes the circulation pattern, and it causes the sea level to rise. Arguably, it's thought there's about 7 meters equivalent of sea level rise within that in a Greenland ice sheet. It's not all going to happen at once, but you need to know it. The context for these things I'm going to show you is also, this was, I think I did that on Saturday night, a current world population. Nobody knows if the world can produce enough food to feed 10 million people. Politicians will tell you, yes, we can. We just need to take more of your land, cut down more of your trees, But nobody really knows that. This is called the Malthusian problem, after a guy called Malthus, who was the first person a very long time ago to try and calculate how many people could live on the earth. There are more current calculations, and I think tonight when we see some of the presentation from Kieran and from Giles and Tom, we're going to see things measured in the equivalent of hectares of what it takes the earth to produce. One thing that's always puzzled me about the ecological footprint is we know from these calculations that Earth has been exceeding what it can produce for quite a long time. So somewhere, somehow, there's a kind of ecological overdraft. You've maybe never had an overdraft, but yeah, sometimes if you spend a little more than you currently have in your account, you have to make it up next month. Nobody knows how to make that up. It's politically unacceptable anywhere in the world to say there are too many people. Voluntarily, we know with animals that their reproductive systems, when they overrun their resources, they stop producing children. But humans don't. We kind of bypassed all of that. There are no constraints on us. This is kind of super interesting. This map is produced every year. If everybody lived like Jamaica, people do in Jamaica, the world would be pretty much okay in ecological resources. If we look at the other end, if we look at February, if everybody lived like they do in Qatar, if the whole world did, it would be a terrible catastrophe. Different countries and different cultures use different amounts of energy, use different amounts of and waste of food and principally of water. Okay. This is a quotation from Hansen. Hansen is a personal hero of mine, but for anyone who studies climate science, he was the first person to stand up to the US Congress and say, you are changing the climate. And they very nearly tried to ruin his career, but he was one of the first climate scientists to take on governments. Along with many other scientists, although they're not allowed to say it very often in public, very few believe there's any credible path to 1.5 degrees change. Very few. Mathematically, there's a tiny bit possibility that it is possible. If everyone came to their senses tomorrow and all the governments agreed with each other and everybody did everything, it's possible you could slow down climate change enough that it would take a much longer time to reach 1.5. But whoever heard of governments that sensible? Whoever heard of them cooperating like that? They just don't. Okay. I want to ask you to think during this week for students, where will you be in 2050? It's not very far away. Let's say in 25 years' time. You're laughing, but what I mean is you might be running your own practice. If you're not, you're certainly going to be senior designers running big parts. If you want to make your life in big practice, you'll be team leaders. You'll have responsibilities. What kind of projects will you be doing? How will you change and understand what needs to be done? How will you convince people? And 50 years from now, you are going to be that old one day. You don't believe it today, but believe it's going to happen. Right? And maybe then you'll be as concerned as I am. And I hope some of you will be here to tell the next generation why they should be so concerned, why you should be so concerned. Yes. You're going to learn how to deal with that this year. So I'm going to run back to a little bit more than 100 years. Young architect, I think he was 24 years old when he said this. Kind of current age of people at the A, Sant'Elia. He died not long after in the First World War. And what he meant by every generation must build its own city is that it's a project of the imagination. It's not necessarily what passes for new urban design today, which is kind of some nice funky geometry with some green bits on it. And you've all seen visions of new cities in Dizine and other places, which are, nice bit of geometry, and it's all green. And it has no sense or value at all. So he was talking. And you may know or not know of these drawings, 24 years old, and there had been nothing built like this before. And quite a lot of what we see in the world today descends almost directly from this. And what he's talking about was an architecture of calculation. And the reason he said calculation was it didn't necessarily mean you have to do an awful lot of maths. But what he's saying is you think of cities not only as the fixed buildings, but as systems of movements and dynamics of change. Yes? Flow. Nowadays we talk about flows, spaces of flows. Excuse me. Architecture 101, you've all seen this in your first year, or you should have done. So ideas about a contemporary city, you're going to see repeated a lot in nowadays recycled. The thing about this is not the funky shape of the towers in the middle, but the fact that the elite lived in the middle and the rest of us lived on the outside. And even on the outside of this was a proposed city for 3 million people. We might well have been even outside of that, the whole model. You will see this idea revisited in a very famous project in a little while. This is Hilbersheimer also having a go at designing a new city. We're still around, I'm looking over there, but I think this is about late 1920s, and I've forgotten the date, I'm afraid. But what we're talking about then is the transport system. That's with those little black dots there, very sweetly, those are the cars. There are trains underneath. And every block is the same. And the endless repetition. So these are 60 by 100 meters above ground, 5 stories below ground. Broadacre City was something different, which is partly a political idea that, from Frank Lloyd Wright. It was 1935, and this plan was for something like a 10 square kilometer area, and it was exhibited first in New York. Perhaps the best thing that to remember about Frank Lloyd Wright is he was the author of the idea that every person should have their own acre. They should all have their piece of land. The other thing to remember about him, he thought the only person who could be responsible to run a city like this was an architect. So he didn't always convince people, let's say, of the rationality of this view. This is from a 1930 sci-fi musical comedy film, a set drawn and made by architectural students. So around about 1930, we're seeing, at least in the imagination, the whole of the vision of a contemporary city. And you will find visions not completely unlike this in many cities today. Around about the same time, we start, at least in the US, to experience what were called the dirty 30s. It was a 10 to 12 year drought, which in terms of the climate history of the US is very short. So one of the things to understand when you're studying the history and the climate of a particular place you're interested in, look at the history. The Great Plains of the US were, for a large amount of time in the past, sand dunes. Very common to have in the middle of a continent, to have droughts of 100 years up to 300 years. Climate in the middle of a continent is always very different to climate on the edge. There's water on the edges, normally, to modify it. It's always hotter in the center of a continent and colder in the winter than either of the extremes. This was aggravated, let's say, by very poor agricultural practices that in an enlightened society we wouldn't do today unless you exist in England. And I'll explain a little more about English agriculture and its failings later. What this produced, apart from massive dust storms and a very arid condition in which nothing could grow, was a vast migration. Again, this is something we're seeing partly today, but migration in the past in the world has always been triggered by catastrophic climate change. And in some arguments are that all cities originated when the spread out people of the earth experienced climate change and moved to the river valleys. They were known as the Okies, and they fled to California, California being not so populated then. This is a map of the shelter belt. Eventually, they realized, well, if we start to plant trees, that will help to mitigate. And to an extent it did. They planted over 20 million trees, spread right down through the center of the US. The US has never again since then done an ecological project on that scale. And more or less most of those trees, 80 to 90 years on, have gone now and been ploughed under. And it's one of the things that Trump forbade people to talk about in the US in ecological science, that the center and the plains are very vulnerable again to drought and climate change. We are seeing in some parts of the world that same project repeated. China has a massive project for planting trees to hold back their Gobi Desert. And in Africa, the Sahel project goes right across Africa, just below the Sahara. Will it work? Nobody's quite sure. It works for a while. But a profound climate change cannot hold back the deserts. And you can never quite have enough water to maintain all the trees at the same time as a desert is blowing sand and expanding over it. These are refugees arriving in the UK in the 1950s from the Basque Civil War. I'm not going to talk at all today about the two current wars the world has experienced, but I will say at my advanced age, I do not remember a time when there wasn't a war somewhere in the world. And I do remember, I've looked up, in the First World War, 3% of the casualties were civilians. In the current wars, more than 90%, I'm sure. No one is telling us, but we know it must be. The war also has a profound effect, firstly in migration, but it produces and toxifies and changes the surface of the land. So it becomes very, very difficult to grow and recover from. Okay, so I'm going to talk a little bit about the future of the future. This is the World of Tomorrow, sponsored, of course, by General Motors. And the interesting thing is it was in the World's Fair, and down below you can see this wonderful model of what the future of the world cities would be. And if you look very carefully at this image, you can see these people sitting up there admiring it, separated by glass. And it's a spectacle. Principally, it was funded and organized by the motor car industry. And we know the outcome of that. Right the way across the US, in many parts of the world, we still see urban planning that is dominated by road traffic. And the legacy is still with us from this kind of attitude. Okay, so the new city, often it had those titles. Lots of architects made books about their version of the new city. They were always driven by the promise of a kind of technological euphoria. We have it today. We have politicians and people who say, don't worry about climate change in the future. You know, somebody's going to invent a way of snatching carbon out of the air. We can grow, you know, whole acres of wheat on this little table. Somebody will invent something. So, social liberation is a more difficult thing to calculate, because by and large, across the world, most of us lead much better lives than our grandparents did. But there are large parts of the world where people are disenfranchised and can make no progress and do not have access to the things that we do. Okay. The other amazing thing about all the every kind of new city and utopian dreams of architects from around about 1920, at least until the 60s, there's no weather, there's no climate. And in the drawings and in the models, the sky is blue. There's no agricultural failure, there are no droughts. There are no torrential downfalls that drown our food in our homes. New calculations start around 1940. This is an aerial photograph of the Tokyo firestorm. What is rarely published is the mathematical study and the simulation that was done before this to create a firestorm that would consume a city, could not be put out by any means. And of course, not long after, there was Hiroshima. So not only have humans acted against nature and exacerbated and increased climate change, they have also acted to increase all the other risks simultaneously. Okay. Immediately after the war, we start to get the ideas of the agrarian city, an agricultural city. But the amazing thing is it looks exactly the same as the industrial city from the 1930s. It's got the same organization of blocks. It's got a central railway or transit system. There's just more countryside stuff around it. And of course, this was Hilbersheimer again. It emigrated to the US by then, no longer a communist and become a good capitalist. But it's essentially the same project. We start to see the development of that idea in Tokyo Bay. This is Kenzo Tange's project. There's a central spine, and that's where all the cars, the subway trains and the railway trains would be at the lower levels, and the pedestrian and summary areas would be in the center. And of course, it's, everything is blue. So all the social facilities would be within that central spine. And the outlying areas that you see in this rather, I think, quite beautiful little model would be these kind of housing combines out in the bay. 1969, Super Studio, this is called a continuous monument. It's an architectural model for, in their view, total urbanization. This is something, a rectilinear grid that would extend right around the world and would enclose, it would be the same, looking like this, in every environment found on the planet. And everything seemingly could happen within that. But most of the drawings are like this, and I remember as a student thinking, what an amazing drawing, I wish I could make things like that. The logic seemed to be, and was never really fully explained, that this uniform grid would somehow liberate people, that people could wander freely. There was never any sense of how you make a home in anything like that, and everyone was kind of young and didn't have to worry about the end of half term and getting the kids to school and so forth. This is called New Babylon by a very interesting guy called Constant. And he was what nowadays you would call, I guess, an urban geographer. And again, he's talking about all land should be owned collectively. Everything is produced automatically. Nobody has to work. And you have a life of randomly drifting through these spaces. Okay. At the same time as those sets of ideas, in the sciences, what you were seeing were the first really severe criticisms. Around 1957, Richard Revelle was saying, again to the US Congress, and this is a vast geophysical experiment. Nobody knows what is happening, and nobody knows really why you're doing this, but what you're doing is burning fossil fuels that took millions of years to accumulate. The danger of CO2 and global warming, and the climate would slowly respond, has been known now since then, about 70 years. At the time it was dismissed because they say, well, look, the climate this year is not any different to last year, so obviously it's not going to make any difference. Or they might went as far as saying, the last 5 years. But climate is very slow to respond until it reaches a critical threshold, and then it's very rapid. 67, Rudolph, who I think was the dean of Yale for about this time. This is the Lower Manhattan Expressway. It's a mega structure, and again you can see the inhabitation of that line is what's crucial. The ordinary people live on either side, but the cars and trains are below. Even more extreme. This is by some Ron Heron, who was here, as many of the archogram people were. And his drawing for a walking city. A city that could just go where the resources are, exploit them, use them all up, and then move on to somewhere else. Not long later, we get the first word, arcology, which was coined as a mixture of ecology and architecture. And I think we have a copy of the original set of drawings still in the MTech studio, if anyone would like to see them. There's a whole book of them. City in the Image of Man, I think it's called. These are the days of hand-drawn ink rendered things. Soleri, some of you may know as the architect of Arcosanti. So in his favor, he lived his whole life for this dream and attempted to build a part of it in, I think it's the Arizona desert. The lean linear city. So what he's talking about is a kind of artery that would thread along, and there's a series of modules. And they're never quite clear whether the land outside it is agriculture produced for the city or by people in the city, or whether it's just, in his most extreme drawings, the outside is just the outside. Nobody goes there. The best interpretation is that, in some of his drawings, it seems to imply he would leave the rest of the world to regenerate naturally. Okay. J.G. Ballard wrote, one of the great writers of science fiction. He wrote a book called Concentration City. And within the book, it's an assumption that there's one continuous construction that goes all the way around the world. And the protagonist is a student who starts to explore this and eventually ends up where he started after 10 days of traveling. This is the line. You've seen this, right? You're laughing because you know what it is. Okay. It's 170 kilometers long, and it's less than the width of Bedford Square. And it runs from the sea to the mountains. It has a mirror surface. Nobody quite knows why there's a mirror on the outside, but the outside is definitely the outside. And there's one little boast somewhere in the NEOM site. You can go outside, and there's a little picture of a hole in this thing with a small terrace up in the mountains. It's powered by renewable energy, and guess what? It has the same system of transit and water pipes, fresh water produced by desalination plants and pumped along its 170 kilometers. It's estimated, or the design estimate is 9 million people, which I think is somewhere around a quarter of the population of Saudi. Nobody knows what's going to happen to the other 3/4. Maybe they'll stay somewhere else. Everything comes from somewhere else. Some of the renderings. This is what we call greenwashing, right? It's essentially the same renderings that we saw, or I saw 30 years ago for new office blocks. It's the same kind of thing, but there's a lot more green attached to it. And there's a little kind of series of ponds or terraces down there. 9 million people, the amount of food cannot be produced in this. The amount of water can't be done by one salination plant for 9 million people. Okay. Architectural ideas get recycled, and each recycling seems to make them weaker and worse. And you're not going to do that, are you? We're asking you this week not to do that, to find new things, and I'll explain about that in a minute. There's a little bit more of the doom before we move to the optimism. Okay. This is Agent Orange, an amazing invention which will kill plants for 30 years and produce birth defects for 3 generations. So technology is also amazing at producing. We produce agricultural materials that will boost growth for 2 or 3 years, but the runoff from them kills all the fish life in the rivers. Fertilization of the land, as it grows more and more exploited and more sterile, has these unpredicted side effects. Don't go swimming in an English river. It's full of human shit. It's full of runoffs from agriculture. People get super ill, right? So I know she's a swimmer. Yeah. And I have a little, because I love to swim, I have a little app on my phone, and I live on the coast, that tells me where the last sewage discharge was from a water company near where I live. So I know the pattern of the currents, and it warns me, don't swim there the next 6 to 10 days. Apologies to Beijing, which is a city I really admire and love, but having visited recently, partly this is due to a natural inversion because it's in a bowl and air gets trapped, but it's also produced by the huge numbers of cars. China is doing something about it. They have removed many old cars, and they have the highest plantation of trees of any country in the world at the moment. But it's a very long and very big battle for them. This is the zone. This is the product of Chernobyl. Actually, you can take an eco trip to Chernobyl now. You can go for a visit, and you have to wear a nice little suit and dosimeter. What they won't show you are the deformed animal and human life there. But it is possible to see that such areas, when it looks like this, over a period of 30 or 40 years, can make an ecological recovery. But we make an awful lot of stuff that's very difficult to dispose of without producing long-lasting toxins. And this is one of the worst. The heavy chemicals involved in taking these apart, and oil tankers particularly, produce toxins that will be in those soils and in those people for a very long time. And this is what became of the idea that every person should have their own acre. It's as if you fly into Los Angeles in the daytime, you will spend 30 to 40 minutes passing over this, what looks like a really brown carpet. And if you live here, there are places where you'd have to travel 8 or 10 miles down before you can cross to the other side. So these infrastructures, there's a separate and divide. And we built this. Anyone recognize this? This is Delhi. We built huge amounts of urban tissue that is totally undifferentiated, which it has no natural ecology, and there's no natural landscape to support it. And perhaps most famous is Mexico City. And what we need to remember when we talk about new cities and improving cities is the city is on the skyline, but a significant portion of humanity lives down there in much less privileged circumstances than we do. It's argued that there isn't a meter of the Earth's surface that has not been affected by humans. In some cases like this, these are an ecological engineering that both preserves the landscape, produces food, and in some ways is as close as you can get to a productive ecology that is not ruinous. But these two are being replaced by this. If you had orange juice, fresh fruit for breakfast this morning in UK, this is where it came from. The soil underneath these, because they use very cheap plastics to decay, UV decay in sunlight. In parts of Spain where you can go, if you dig a meter down, you will see it looks like a phyllo pastry. It's just micro thin layers of plastic. And they don't worry about the soil condition because everything is fertilized and it's just entirely chemical agricultural production. And the cost of this lecture and all this wonderful AV equipment and my laptop and this and my iPhone is this. And we produce huge amounts of plastic. Now, plastic is only, I think, about 3% or 5% responsible for increase in carbon. But it's responsible for far more in the degradation of land, of landscapes. And some of the rare earths and rare minerals we use produce toxins that have a half-life of 500 years. There hasn't been an in-depth study in science of chemical pollution to the same level that there has of atmospheric or oceanic pollution. But it is acknowledged, and this is an area for the future. And you've seen in your own country either this, or sometimes both, and you've probably seen that, or its equivalent. The migrants that we see there, in English politics, these are demons. Migrants are going to steal your wife, steal your home, take your job, they're going to destroy everything. This is a politician's view. These are people who are fleeing oppression, often disenfranchisement. They have nowhere to go because their lives, both their world that they lived in has been destroyed. So you face something like this, at least a comparable situation to St. Elia, and you're about the same age. So what that generation of architects were facing great social pressures that came from very large populations that were disenfranchised, that have no rights, no access to living conditions, couldn't be changed, oppressed by warfare, socially explosive technologies, and you're also facing this part, an implacably unenlightened and repressive orthodoxy. And that's not just in your governments, that's also within clients and certain architectural practices. But you have an advantage, that the ability for you to understand the dynamics of the world, the information is free. And we're going to help you try to find that this year, and particularly this week. And what we're asking and what you should be thinking about for your lifetime's work is a synergy of ecology and climate, and particularly social and spatial culture. Spatial cultures are amongst the biggest tragedy of loss in architecture. So, when you're my age, will there be songs of lost cities, voices singing out of empty cisterns and exhausted worlds? That's a quote from The Wasteland, T.S. Eliot. Like the wanderer over the mist that I opened this talk with, will you be that solitary figure looking at enormous dust storms? But it doesn't need to be like that. That's the worst possible outcome. And it may be that that will happen in some parts of the world, but it need not happen. And what we ask you to do is to find out very particular things about particular places. There's no generic solutions to anything. But you can start by dreaming of landscapes and architects that are in synergy with the climate and ecology of a particular place. And everything you do counts. If you start with one garden, one room, one house, one urban block, one village, one community, one town, all of that counts. Society needs to tread more lightly on the earth, and as architects we need to show people how to do that. It's not enough to tell them, don't do this, don't do that. We need a more positive thing. We need you to be thinking and designing of how you can do that, what new ways we can find of living. And that's what this week is for. And we're going to see lots of presentations this week of people who are doing their own small thing or medium-sized thing. And all of the students, I think, Milad, we have 20 presentations or more. Yeah, we have almost 20 presentations by students on Friday already booked. Okay, so by the end of the week, we will know what can be done now and we will also be asking you to think what you can do in the future. There we are. Thank you.